Even if I've already explained some details about the transport addressing, to the transport layer addressing, um, it's very important to review these concepts and perhaps add some details. Then, when we talk about the transport layer addressing, we are talking about the port numbers. The transport addresses then are extensions, an extension of the internet addressing. Addressing with IP addresses enable communication between computers on the internet, but in fact, what we need is the communication between processes. Then the two transport protocols, TCP and UDP, enable that kind of communication between processes, what we call IPC, inter-process communication. For this purpose, an addressing scheme is required that supports the computer internal distribution of packets. That is a multiplexing of the packets exchanged between hosts. But in order to multiplex the communication between not only hosts but processes within the host. These communication endpoints are called ports or port numbers. A port is the connection between the user process and the TCP/IP software. That is, it's a number and a number of 16 bits. For a clear description of an internet connection, five tuple, that is 5 parameters, is therefore sufficient. This consists of the transport protocol, that is the number that identifies the TCP or the UDP transport protocol, and a pair of internet address and ports for each endpoint. The local port numbers are usually assigned sequentially for each new connection until an overflow occurs. Those are the ports called ephemeral ports. After that, it starts all over again. That is the assignation of those ports of the ephemeral ports. It's an assignation that that starts each time the system is restarted. Alternatively, however, a process can also specify a port number which is then assigned if it is unoccupied. That is always the new processes that need to communicate with other processes in other host or in the same host using TCP/IP protocol suite. In fact, need to get a free local port or a free ephemeral port. The server can therefore determine its port when establishing a connection. If a client knows this port, communication is possible. That is, the server uses the typical reserved port, and that is a reserved port for a particular well-known service. And in that way, in fact, the client could establish the communication with the server because the client knows in which port the server is listening the requests or the information that the client needs. Another, these services are addressed using a fixed port called a reserved port that always remains the same. For this purpose, there is a list in which the assignment of service names to port protocol pairs is recorded. To prevent misuse, the ports are divided into privileged and unprivileged ports. Typically, the ports under 1024 are privileged port numbers and are only assigned to processes with root privileges, that is, with administrative privileges in the platform. Instead of that, the ports over 1024 are unprivileged ports, and those ports could be assigned to any process, not only privileged processes. In this table, we could see that the assignment of the reserved ports associated with each well-known service. Then we will study particularly some of those cases of protocols, but typically one of the most used is, for instance, HTTP, that use the reserved port 80 over TCP, or for instance, HTTPS, that is Hypertext Transport Protocol Secured, that use the reserved port 443, or the SMTP, the Simple Message Transfer Protocol, that we use to send and receive mails over the TCP/IP networks. And in the case of SMTP, the reserved port is the number 25, and SMTP runs over TCP.